Hello, welcome everyone. Thank you for tuning in to the QX Day. It's an honor to be able to speak to you today about a very important subject, namely code reviews. Code reviews are sometimes, they're important, but sometimes underappreciated part of the software development process and the quality process. The code reviews have very many different uses and many reasons why you want to do code reviews. Well, one of the reasons, for example, is it can prevent bad code from reaching your production environment. Why is that important? Well, every year, many companies lose lots of money, millions of euros, to faulty software. One such example is American company AT&T. In 1990, a very long time ago, they had an issue in their production code. For those who don't know, AT&T is an American telecom company. And due to a fault in the software, each of their networks was slowly, one by one, going offline. They were crashing. The result, 60 million in losses due to lost phone calls, $60 million. And that's only for AT&T. Of course, there are many other companies that also lost revenue due to these issues. And what was the culprit? One single line of code. For the developers watching, it was a faulty break statement or a misplaced break statement that caused it all. It could probably very easily been caught in a code review. Hopefully that highlights the importance. Of course, preventing bad code isn't just the only reason why you want to do code reviews. Code reviews also help your teams teach each other, help your teams learn from each other, and also helps your code stay consistent. So many reasons why you should take code reviews seriously. What will I be talking about today? First of all, I'll be explaining what code reviews are, how they fit into the whole process, how they should be done. I will be giving a sort of guide on how I do code reviews, what questions I ask myself, and also how to collaborate with your team. So how do you give feedback, and how do you make sure that everyone is code reviewing the code properly. Now, before we get right into it, I'd like to quickly introduce myself. My name is Edward van Lieshout. I'm a front-end developer at Sogeti. I've worked at several clients, the Dutch Chamber of Commerce, the Dutch Probation Office, Dutch Police, and now I'm working for the CIBG, which is part of the Dutch Ministry of Public Health and Sports. I've seen quite a few different code review strategies, processes, and I've also written a lot of code reviews, or done a lot of code reviews myself. So I've seen some things that work really well, and some things that don't work so well, encountered multiple problems, and hopefully I can share these experiences with you today. So let's jump right into it. First thing we want to know, what is a code review? In case you don't know what a code review is, of course, this is an important question you need to ask because there are multiple types of code review. For example, you could also do a code review when a product's going to be released, and then you might have a code review that goes through all the code. That's not what I'm going to be talking about today. Today I'm going to be talking about code reviews that are done when small bits of code are added to a new to a main development branch. So this is before it reaches production. So you still have plenty of time to fix stuff and change stuff before any deadlines. And what does it look like? Here's an example. This isn't the complete code review, but this is what a reviewer sees when he is reviewing code. You can see a whole line of, you can see all the lines of the files that have been changed. You see some green lines here. That's the code that's been added. And you see the red lines. That's the code that's been deleted. You can click on any of the lines to add a comment. And what's not shown in this image is once you've done that, you can either press accept, like that you tell the developer, I approve this, and this can be merged to the develop branch. And there's some other options. You can also say needs changes. You can approve with suggestions. So there are many options. I'll talk about that a bit more later. There are also some things that don't constitute a code review. Most notably, running the app and running the automated tests. A code review is purely about the code itself. And running the app and the automated tests are things that are already picked up somewhere else. For example, if you have a tester in your team, hopefully, then running the app is something that a tester might do to ensure that it actually works functionally how it's supposed to. And moreover, the automated tests can be checked automatically. Normally, when you have a pull request, which is when you want to move code to the next level, you have a so-called pipeline, which will run several steps, including the automated tests. So as a reviewer, you don't have to do that in the most cases, because that will be picked up automatically. Of course, if you don't have a pipeline or whatever, then feel free to pick this up anyways. But in most cases, it's not necessary. Now, before you can start doing a pull request, you need to get to the first step, which is when a developer has finished building a feature or finished writing some code, and he wants to merge this feature to the develop branch. Well, in order to do that, the developer will make a pull request, and there are some things that developers should do before making people review the pull request. First of all, the pull request needs to have a certain amount of context so that the developer who's doing a review can understand what they're looking at. Not that it's just some lines of code, but for example, if you're working with Jira, you'd want the pull request to be linked to a certain Jira ticket number so that the developer who's reviewing can have a look at the code and have a look at what it's supposed to do. That will give the developer the required context in order to be able to critically look at the code. Also important is that the pull request is not too long, because, well, as I am developer on Twitter says, 10 lines of code equals 10 issues, 500 lines of code equals looks fine. If a pull request is too long, it can be very hard to look critically, because it gets very tempting to skim over the changed lines of code globally, which means you're not looking critically at the pull request anymore, you're not looking critically at the code, and you can miss many potential issues, which is important, because in the example I stated at the start, one line of code can make all the difference. So yeah, more on that later. I will also talk about some strategies on how to make your pull requests shorter. Another thing to look out for is, who do you ask to review your code once you've made a pull request? Since, well, of course, everyone in the team has their own hats, their own strengths, their own weaknesses. And of course, you want to invite the people to review your code who are most suitable for to look critically at the code. Another thing to think about is, most of the time, it's developers who are doing the code reviews. That's not necessary, though. Sometimes you might ask a tester to review your code, especially if it's a tester who also does some development here and there, a dev tester. But even just a normal tester, you might want to invite them to look at your unit tests. But also an architect, especially if you're working on like a new project, you might ask the architect to look at something if it has impact on the overall on certain code patterns or the overall architecture of the application. So yeah, think about who do you want to have review your code. Now, these are all the preparations to being able to ask your developers or other teammates to do code review. Now I'm going to tell you how I do my code reviews. I'm going to highlight some questions that I ask myself and show you some examples. I'll be showing some code examples as well. I know not everyone watching is a developer. It's not going to be specifically about the code. It's more about the general concepts. But some code examples always helps to really see what it's about. As I'm a front-end developer, most of the code examples will be JavaScript, and TypeScript, but most of these things go for multiple programming languages. All right, so the first question to ask yourself, in my opinion, is, do I understand what the code I'm reviewing does? And that's not necessarily a question that you ask for the review itself. This is more of a preparation question, because if you don't know what the code is, you can't give a proper review. So yeah, there's some things that you should do before you actually review the code to make sure that you properly understand what the code does, so you can critically look at the code. First of all, the context, as I stated earlier about the pull requests. The pull request should have enough context so that as a developer you can, or anybody who's doing a review, you can understand what the story is about. If you don't know the context and you're just looking at lines of code, then it might not mean so much to you as if you know what's actually supposed to be built with the pull request. So that's the first thing. Second thing is, read every line. This is very important because, as stated, the network crash that occurred in 1990 at AT&T was due to one faulty line of code. So if you just globally skim through the code, you might miss that one line, and that could cause big issues. So read every line, because otherwise you're not critically looking at the code in the way that you should be. Of course, also, you need to actually understand what the code is doing. Maybe if you're a new developer, you don't know everything yet. You might encounter some code that you don't understand. In that case, either look it up or ask the developer who wrote it, what does this line of code do? Like that you can learn from your teammates or from Google. And you might just spot something that's maybe not ideal just by asking such questions. All right, moving on. The next question that I ask myself, is the code more complex than necessary? Now, this is mostly for the maintainability of the code. So if code is more complex than necessary, it's not necessarily going to mean that there are bugs. Well, it is possible, of course, but most important is that you keep the code maintainable by asking this question. Now, lots of things regarding to this question can be automated. Things that you'll do to keep your code clean. You can put a code analysis tool on your project, and the code analysis tool will give you a whole list of things that you can improve to make the code less complex. But there are some things that I also recommend looking for in the pull requests. For example, variable names. Again, this is something that can sort of be automated, but not completely, because there's too much room for interpretation. One thing you should be aware of, everyone has their own definition of what is a good variable name, and each team has their own standards as well. But there are some good practices you can look out for. For example, abbreviated variable names. As you can see in the example here on the left, person has been abbreviated to the letter P. Sometimes it can be very tempting to keep variable names short, because like that, the code is shorter. And you might have the illusion that it's more legible due to the text being shorter. But in a complicated application, you don't want to look at the letter P and then have to work out that, oh, the P stands for person in this case. So a little bit verbose isn't bad. Of course, you don't want to make everything much too long, but at least make it descriptive enough that people can understand it. Other problem can be names that are too ambiguous. So on the left here, I have a function called handle data. Well, that's of course very ambiguous, since almost everything in software development is handling data. So this could mean literally everything. So yeah, on the right, I have a slightly more verbose function name, but at least it's slightly more specific, and anyone looking at it can much more easily understand what's happening within that function. Now, a bit similar to this one is, of course, functions that are too long. And now this example isn't that good, since these functions aren't long at all, but it's just to sort of illustrate that functions can be split up. This is the function from last slide, which I then split up into to slightly more specific functions. This is also something that can be automated with SonarQube, but this is one of the things that I see the most often, that you have really long functions, and it makes it very hard to read for your developers, because you just have huge blocks of text that you can't make sense of it anymore. Next up, we have overengineering. Now, for the layman here, I have this image of an airplane to sort of explain what overengineering is. Here you can see an airplane. I'm pretty sure it's not a real airplane, but it doesn't matter. This airplane has over 20 motors, and well, I'm sure it took a lot of craftsmanship to make it. And it looks really cool, and it probably works fine for certain situations. However, these situations you will never reach. The airplane will fly just fine with just 2 motors. So all these extra motors, in this case, aren't necessary. So that's sort of what overengineering is, and there are many ways that overengineering can creep into your code. For example, making something overly generic can be a sign of overengineering. You might want to add all these edge cases to a certain class to make sure that in the future you can handle certain stuff, but you need to stay critical. Are these future situations really going to happen? Because maybe you're making your code more complex than is actually necessary. Another thing that can happen is there are certain programming languages where you can define your own types. TypeScript is an example, like a type of something, for example, a string or an integer, but you can also make your own ones. And sometimes it can be tempting to try and make the perfect type for everything, just so that it perfectly describes a certain object or whatever. It can be really handy in some cases, but in some cases it can also be just not necessary, and you're adding lots of complicated types that just make the code more complex than is necessary. Finally, and this is something that's I sometimes I'm also guilty of myself. These days, a lot of programming languages have lots of new features that allow you to put lots of functionality into one line. Now, just a bit ago, I was talking about too long functions, functions that are too many lines. Well, you can also put one function in one very, very long line, but that's, of course, even less legible. Well, here's an example. I have no idea what this line of code does. It's very complicated. I know that the guy who wrote this is watching right now, so shout out to him. If you see something like this, then, of course, split it up into multiple lines so that it's slightly more legible. Of course, use your common sense. Sometimes lots of lines is also not handy, and sometimes it can save a bit of time and effort just to put something in, some multiple stuff in one line. So try to use your common sense. Right, now let's move on to the next question. Can the code result in a poorer performance? And the main reason why you want to sort of look out for this stuff in a code review is it's much easier to fix if you catch it in a code review than if you find out about it 2 months later because you have a memory leak which is causing your program to have poor performance. Well, then try and work out what's causing it. That can be really difficult sometimes. So if you can catch it during the code review, that helps a lot. Now, some examples. This can occur in multiple programming languages where you have properties that your properties for certain objects take up data in a server or a computer or whatever, take up memory, and the more data you're using, the more memory you're using, the poorer the performance can be. For example, imagine you have a program that has 100 instances of a cat. And maybe you want to know some stuff about the cat, such as what species it is, what its name is. But maybe you also want to know from the cat what the scientific name of a cat is. Off the top of my head, Felis catus or whatever. If you want to retrieve this information from the cat instances, then it is useful to have it as a variable, but you don't want to have 100 times the same property copied over all 100 cats, because that's just taking up too much memory, or yes, unnecessary memory is what I mean to say. Because, well, all 100 cats have the same scientific name. So in this case, you can use static properties like this, the properties only being saved once. And that can, in a big application, that can make the difference. Same goes for static methods. If you have a helper function that doesn't need to be copied across multiple instances of something, you can make the application a bit more performant. Another thing that is often a thing, and this really depends on the programming language, is memory leaks. Now, of course, if you go back to the older languages, this is more of a problem, because some older languages, you really need to manually do everything. You need to manually start operations, and you need to manually close them. Well, so some of the newer programming languages have less of that problem. But still, there are some things that you need to look out for. In my case, I have an example with Angular, JavaScript. Usually, that's a programming language that doesn't have this problem quite as much. But in Angular, for example, you have so-called observables, which are, in fact, processes that are started and then closed. A lot of times, this will be done automatically for you, but there can be some situations where you want to, where you need to close it yourself. Otherwise, you can risk having a memory leak. Well, in Angular, there are two ways you can do it. I have, since I made this example, learned that the left example is not the best practice, but on the right, you have an async pipe, and that is a very good way to automatically close your processes that are running. So that's all for poor performance. Next, what I like to look at, and this is not going to be a big deal for some languages, but I like to ask myself, does the code do what I expect it to? Now, this isn't a question of running the application and seeing, does it do what I expect it to do? This is like looking, this is a risk, unexpected behavior occurring if I have this code in my application. And JavaScript is, of course, sort of renowned for not always doing what you expect it to. Well, here are some examples of unexpected behavior in JavaScript. Now, all of this can be prevented by using the language the way it's supposed to be used. And of course, you also these days have TypeScript. You can define types in TypeScript, and that can also prevent lots of these issues. But of course, you do need to give everything a type if you want this to work. So that's something you can look out for in code reviews when working with TypeScript. Finally, also very important is the unit tests. Unit tests aren't exactly part of the code, but they also kind of are, because they're what makes sure that the code works how you want it to. Now, there are some things that I recommend looking at when checking the unit tests. First of all, very important, are the tests useful? Because I think all developers have before seen a unit test that doesn't actually test anything. So that's the first thing to look out for. Second of all, the test cases. You have multiple things that you want to test, and well, when checking the code, have a look at, are the test cases being hit? Maybe the developer missed something, so it's very important to really double check that. Finally, unit tests are themselves also code, so just like that you would review any other piece of code, you need to see that have a look that the code is up to standards. And finally, the code legibility. You want the tests to be legible, you want to understand what the tests are doing. And sometimes a unit test can end up being much too complicated. So for that reason, it's useful to also, like in your code, describe what does the test do, describe and split up the arrange, the act, and the assert, so that people reading the code can instantly see, okay, this is what the unit test does. Now, once you've checked all of that, you can do a final check. Well, it's not a separate check that I would do necessarily, but you want to make sure that the code has also been cleaned up Again, this is something that will be picked up by SonarCube. A code analysis tool will work these things out for you. But if you come across something in the code, then make a comment, because maybe the developer doesn't have something configured correctly in their IDE. So things you can check for are, example, commented code, so code that's being commented out and it's not being put in use. Console and print statements. Generally, you don't want those in a production environment, so those have to be cleaned out before being merged. To-dos and fix-me's, so these are comments that describe something that still needs to be done. Those can still be in there, but if they're there, it's best to link it to a ticket number so that people can see, okay, this is when it's going to be picked up. And finally, something like linting and style, so that's, so for example, the right indentation in your code. Again, something that will be picked up automatically, but if a developer isn't doing this correctly, they maybe don't have the linter properly configured. Now, a very important thing when it comes to coding, code reviews is also the coding standards defined in your development team or your company, because very important part of code maintainability is consistency. So make sure that when you're doing a review, you also sort of know what the coding standards are, so you can also critically look at that, make sure that the other developers are keeping up to those standards so that the code eventually can be fully consistent. Once you've checked all these things, then, well, you've pretty much finished your pull request. Now, of course, if you have some comments, it's time to start writing some feedback, and that's a very important. It's very important that you do that right, since it can cause issues if you give bad feedback to your teammates. So, first part is you need to be clear and concise. The developer who receives feedback needs to understand what he needs to change and why it needs to be changed. So, when you write a comment, be clear. What do you want to be changed? What should it be changed to? So what should the end scenario be? And why do you want it to be changed? So for example, instead of saying, please change please change ID to user ID, say, please change user ID to, or please change ID to user ID, so that it can't be confused anymore with document ID. Just an example. Explain why, because then that can prevent discussion with your teammates. Besides this, it's also important to be compassionate. Well, I think many developers have experienced some discussions within code reviews and maybe even experienced arguments with developers. I have myself. So it's important to be compassionate. Don't be judgmental, don't think that you have the right answer straight away, but be inquisitive. Ask the developer, why did you do this? Well, maybe not exactly like that, but at least don't make assumptions. Be polite, and for example, don't say, this code sucks, but but just ask questions, for example. If a comment starts a discussion, that can happen, that the developer doesn't agree with your feedback. If a discussion starts, then arrange a phone call with your colleague so that you can discuss it on Teams or on WebEx or whatever. Because like that, you can much more quickly come to a resolution, and that will, well, of course, they're paying you lots of money, so you want to get it resolved as fast as possible. Now, the other question to ask yourself is, when do I press accept? Maybe you've done your code review, you've added some comments. Do I press accept or not? Well, this is something that's going to depend on multiple things, and in the end, it's a judgment you have to make. But here are some questions you can ask yourself. First of all, judge this decision based on the importance of the feature that needs to be that needs to be merged? Is it something that's completely breaking and you don't have very big issues in, in the code review that you spotted? Then maybe you could, instead of saying needs changes, you could accept accept the code review or the pull request with suggestions like that. If it's really that's necessary that it gets merged straight away, it can be done quickly. So that's the first thing you can judge it on. Second of all, the severity of the issues that you found while doing the code review. If the issues aren't actually that important at all, or if you're not even sure of it yourself, it's just questions you're asking, then you could also say accept with suggestions. Then again, you're giving the other developer the choice, do I want to change this or do I just merge it? And finally, potential time spent fixing these issues that you've commented on. If something will take a very, very, very long time to fix and it's not that important, then again, this can be something that can have an impact on your decision. So yeah, make your own judgment, but these are some things that you can ask yourself. Finally, if you have a team and currently the code review process isn't as you'd like it, there are some things you can do to get it started up. Now, what your code review strategy will be, that's going to depend on a lot of different things. It's going to depend on your project, on your team, on the company that you're working in. But there are some questions you can start asking yourself and some things you can start thinking about to get this process kick-started. First of all, to plan out your Git flow strategy. So, yeah, currently you have pull requests that need to be reviewed. How can you make it that these pull requests are good pull requests? For example, are they too long? Well, there's some things you can do to fix that. You can split up your features into multiple pull requests. For example, instead of splitting up based on the stories, you could split it up on tasks. Like that, you're automatically creating very small pull requests, which can make it much easier to review. Of course, if your pull requests are too long, that might also be a sign that your user stories are too big and that they need to be split up. Another thing you can do is make work in progress pull requests, which means that you have pull requests while you're developing still. Like that, you can have people already have a look at the pull request, even when it's not finished yet, and that can also take some of the load off of it. What you can also look at is what rules do you put on the pull request. So how many people need to look at it, how many people need to press accept, and yeah, stuff like that you can have a look at to make sure that people are actually doing proper reviews. Yeah, also think about the who. Do you put certain rules on who needs to look at it? Because maybe you'll have developers who just ask the most junior developer to look at your code because then he knows that there won't be too many comments on it. Of course, situations like that you want to avoid. So yeah, that sort of rounds it up. Hopefully, you now have acquired knowledge of at least what a pull request is, what a code review is, what the process around it entails, and how you can start writing better pull requests, or I mean code reviews. Thank you, and I see I have 3 minutes left for questions. So
no more questions.
No questions. All right. I have a small crowd in front of me here. Maybe someone here has a question.
You took one of the final sentences was that you'd rather, if you want a very good PR review, that you'd rather not want only juniors to have reviewed the code. Would you say it's advisable not ever to include juniors into code reviews?
I think that you actually do want your juniors to do code reviews because the juniors can learn a lot from reviewing the code, and of course, reviewing code is a skill that you need to acquire. But maybe you'd want to say, well, you have both the junior and a maybe more senior person both do a review on the code, Because like that, the junior can also learn from the more senior person. Also, junior developers can sometimes have very sharp insights that you maybe wouldn't expect from a more senior person, so it can be valuable either way, I think.